Hi everyone. In our previous videos, we have seen about the behavioral patterns of part 1. That means of chain of responsibility, command, interpreter, iterator, mediator, memento, and observer patterns. That which we can say as our fourth unit as per our syllabus. And from this video onwards, we are going to see about behavioral pattern part 2 under our fifth unit. In that first pattern is state pattern. Today we are going to see about the pattern of state. Let us see the introduction about our state pattern. Coming to the introduction of our state pattern, the state pattern allows objects to alter its behavior when its internal state changes. That means the state pattern is a design pattern that allows an object to completely change its behavior depending upon its current internal state. So, based on this introduction, let us see a real-time example for this state pattern. I consider here a best example of an ATM machine which we are seeing every day in our lives, which we are using every day in our lives. I consider here best example of ATM machine for a state design pattern. Suppose ATM machine is used. What the purpose of using this ATM machine? We are using these ATM machines to withdraw amount by using our debit or credit cards. Suppose say ATM machine internal state is no debit card, no debit card inserted. So is there a possibility to get the amount? No. That meaning is debit card is not inserted in the slot of ATM machine. So what an operations we can do is cannot be performed. So the amount cannot be withdrawn from the ATM machine. That means whenever we insert the debit card in the ATM and then we can enter the PIN number and we can withdraw the amount. But we didn't insert an ATM card, a debit card, so we can't perform any operations in that. So let us see the first operation that can be performed by using this ATM machine. So what we can do, what the first internal state will be for this ATM machine is, you can insert the debit card. Whenever we enter into a ATM machine, what we have to do is we have to insert the debit card. And without inserting the debit card, we can't eject the debit card. That means we can't remove the debit card from the ATM machine. And we can't enter the PIN number and we can't withdraw the amount without inserting the debit card into the ATM machine. Because you didn't insert the debit card. So the only operations is insert the debit card that can be only performed. Otherwise we can't perform any other operation. And suppose say once a card is inserted into the machine, the state of machine changes. That means the state of ATM has debited the card. That means debit card inserted in the ATM machine slot. Then what the operation we can do is we can insert the debit. We can't insert the debit card because already we inserted the debit card. So there is no chance to insert the debit card. And you can eject the debit card. Yes, you can remove the debit card because you have already entered the debit card. And you can enter the PIN number and you can withdraw the amount. Because card is already inserted and it allows you to withdraw the amount. So these are the operations we can perform after inserting the debit card. So by seeing this explanation, so if the state is no debit card, it allows some of the certain operations to perform. And if the state has a debit card, meaning already card is inserted, that means it allows some other operations, right? So based on this, the internal state of ATM machine, the behavior will be different. So based on the behavior, the internal behavior of ATM, the operations has been changed. So this is one of the best example we can say for this state design pattern. So, so based on this introduction and the real time example of for this introduction, let us see the intent of our state pattern. So, the intent of state pattern is it allows an object to alter its behavior when its internal state changes, and the object will appear to change its class. So, this is the intent of our state pattern. Allows an object to alter its behavior when its internal state changes. The object will appear to change its class. So, this is the intent of our state pattern. And coming to the next template, as also known as these state, also called as objects for state. This is the one of the another name for the state pattern. And coming to the motivation of our state pattern, coming to the motivation of our state pattern, here I consider a class TCP connection, that represents a network connection. A TCP object can be in one of several different states, that is nothing but established, listen and closed. When a TCP connection object receives request from other object, its response differently depending on its current state. For example, the effect of an open request depends on whether the connection is in its closed state or its established state. The state pattern describes how TCP connection can exhibit different behavior in each state. And the key idea in this pattern is to introduce an abstract class called TCP state to represent the state of the network connections. The TCP state class declares an interface common to all classes that represent different operational states. And the subclass of TCP state implements state specific behavior. For example, the class TCP established and TCP closed implements behavior particular to the established and closed states of TCP connections. And the class TCP connection maintains a state object, that means an instance of a subclass of TCP state, and that represents the current state of the TCP connection. The class TCP connection delegates all state specific requests to its state object, to this state object. The TCP connection uses its TCP state subclass instance to perform operations particular to the state of the connection. And whenever the connection changes the state, the TCP connection object changes the state object it uses. And when the connection goes for established to close, for example, TCP connection will replace its TCP established instance with a TCP closed instance. So, this is one of the example for TCP connections, that which we can say under our motivation. So, let us see our next template, that is nothing but applicability. Coming to the applicability of a state pattern, it uses the state pattern in either of the following cases, that are an object's behavior depends on its state and it must change its behavior at runtime depending on that state. And the operations have large multi-part conditional statements that depends on the object state. This state is usually represented by one or more enumerated constants, and often several operations will contain these same conditional structures. And the state pattern puts each branch of the conditional in a separate class. This lets you treat the object state as an object in its own right that can vary independently from other object. And let us see the next template of structure for a state pattern.